Hello. This is D.G. Kelka. I'll be sharing technical knowledge received over a period of time from various gurus and sources. The purpose of sharing this knowledge is strictly for returning to my community, to whom I'm highly indebted. This audio clip is meant for private circulation only. Today, let's understand mold cooling as applied to plastics injection molding. Cooling conditions have an impact on overall cycle time, component dimensions, aesthetics, shrinkage, warpage, so on and so forth. First of all, we need to understand the mold cooling system in a simple fashion. The slightest difference in mold cooling conditions could add or subtract seconds from the molding cycle, making it profitable or loss-making. Despite this fact, mold cooling, by and large, continues to be a taken-for-granted matter. Like most other technical details, there is more to know about the finer aspects of mold cooling and heat transfer than most of us would bother to imagine. Let's go closer to a few of the basics of mold cooling. Heat rejection. The polymer has been heated in order to be able to be molded. Simple as ever, it has to be cooled before it can be used as a molded component, meaning the heat has to be rejected. The mold has to perform this task very effectively, otherwise the molder may end up losing, as mentioned earlier. Flow of cooling medium. The cooling medium, popularly water, has to do the job of taking away the heat transferred from the polymer to the mold. Even the most effective cooling system won't be able to cool any faster than the ability of the molded part to give up the heat. Nevertheless, the cooling system must do this job really well. Especially if the molded part can give up the heat, a cooling system with necessary flow rate as well as pressure is worth considering. Turbulent flow may be necessary in some cases, however, it may not be necessary always. Mold surface temperature control. As mentioned earlier, cooling conditions have an impact on overall cycle time, component dimensions, aesthetics, shrinkage, warpage, so on and so forth. Mold surface temperature control is critical to achieve the same. Once the molding process has stabilized, observations need to be recorded in the form of a mold temperature grid. This mold temperature grid becomes the first step in analyzing the PVT requirements at various locations of the mold. Having understood these basics well, one can then go ahead with the optimum selection of equipment, which could include cooling towers, mold temperature controllers, chillers, water manifolds, and so on and so forth. I have made a small attempt to increase awareness. Your valuable feedback and suggestions are highly appreciated. Thank you.